In this video, we're going to talk about circle formulas, specifically arc length and area of a sector. So just a quick review from geometry. Circumference of a circle is circumference equals 2 pi r, or circumference equals pi times diameter. Remember that your diameter is twice your radius. The area of a circle formula, area is pi r squared. So you should know both of those formulas. In geometry, you had a formula for arc length. Our book uses S for arc length, so I'm going to use that. In geometry, you had A over 360. We're going to do theta over 360. Remember that when we have Greek variables, they usually are going to be representing an angle measure. So our central angle is theta, so we're going to do that angle over 360 times the circumference formula, which is 2 pi r. Additionally, from geometry, you had a formula for area of a sector. So in geometry, your area of a sector formula was, again, you probably used A over 360. We're going to switch that to theta over 360. So again, theta is representing my central angle, and then we multiply that times the area formula, so pi r squared. Both of those formulas assume that theta is an angle measure in degrees. If we change that to an angle measure that is working in radians, then our formulas change just a little bit. So here we would do arc length is theta over, instead of 360, we would do 2 pi because that's a whole circle in radians, and then we would have 2 pi r. Here the pi's and the 2's are going to cancel out, so we're going to be left with arc length is theta times r. Additionally, we have area of a sector is theta over 2 pi times pi r squared. In this case, only the pi's can cancel out, and we would be left with 1/2 theta r squared. You can write that theta over 2, although I recommend the 1/2 times theta because theta is often a fraction, and then you get fractions and fractions, so it's just a little bit easier to deal with here. All right, so if we look at a couple examples here, find the length of an arc with central angle 75 degrees and radius of 6. So look for the keywords in the problem that tell you what formula to use. So arc length, and then my central angle is in degrees. So I want to use the arc length formula in degrees, so theta over 360 times 2 pi r. Plug in my values. So I have 75 degrees over 360 degrees times 2 times pi times my radius, which was 6 centimeters. Your answer can be given as an exact value or as an approximate value. So if it asks for an exact value, put everything into your calculator with the exception of the pi symbol. So here we get about 2.5. Typically we want to leave that in its fraction form, so we're going to get 5/2. So this is going to give me 5 pi over 2. So remember to write the pi symbol in there. If they ask you for an exact value, then you can go ahead and multiply by the pi. And in this case, we will get about 7.85. So just pay attention to your directions, particularly in your MyMathLab, if they're asking for an exact value or an approximate value. Similarly on the test, the directions will indicate. If they don't, then I would accept either answer. So if we look at B, find the length of an arc. So again, we've got arc length. Central angle is pi over 2. Remember, there's no degree symbol, so that tells me that it's radians. And my radius is 10 centimeters. So we're going to use the arc length formula again for radians. So just theta times r. So we just have pi over 2 times the radius, which is 10. So simplifying for my exact answer, we would just get 5 pi, and our approximate answer would be about 15.71. So moving on to C here, find the area of a sector. So now we know that we're doing the area formula of a sector, and my central angle is 100 degrees. So I'm going to take that area of a sector formula in degrees, which is theta over 360 times pi r squared. So as an exact value, we will get 40 pi over 3, and as a approximate value, we will get about 41.89. Remember, this is area, so this is going to be centimeters squared. Again, in D, we have find the area of a sector, so I know I'm doing that formula, and then my central angle is 2 pi over 3, so that's a radian value. So area of a sector is 1/2 theta r squared. Plugging in our values, we get 1/2 times 2 pi over 3 times 5 squared, and then we can evaluate. So as an exact value, I have 25 pi over 3, and my approximate answer would be about 26.18 centimeters squared. Looking at a couple more examples here. Find the radius of a circle with central angle pi over 3. Notice that is a radian measure, and my arc length is 5 pi. So I know I'm dealing with arc length in radians. So I'm going to grab that formula, which is S equals theta times r. Plugging in what I know here, my arc length is 5 pi, so that's going to be my S. Find the radius, so that's going to stay my variable, and my central angle is pi over 4. So then I'm simply solving for r. Then multiply both sides by 4. Get 20 pi equals pi times r. Dividing both sides by pi, we're going to get r equals 20. The second one, find the area of a 60-degree slice of a large 14-inch diameter pizza. So I know I'm dealing with area here, so I'm going to take the area formula, area of a sector. My angle's in degrees, so I'm going to use the formula theta over 360 times pi r squared. I'm going to plug in my values, so I have 60 degrees over 360 times pi times radius squared. Notice they gave me my diameter, so my radius would be 7. So doing just the approximate answer, we get about 25.66 inches squared. Okay, so in this example, we are looking at these lanes on a running track, and they are 1 meter wide. The inside radius of lane 1 is 33 meters, while the inside radius of lane 2 is 34. How much longer is lane 2 than lane 1 around the turn? So how much longer implies that we're doing distance, and distance would imply that I need to use arc length. If you're doing an area problem, you should see the word area in the problem. When you're doing an arc length formula, you can have any sort of words that imply length, distance, how far, how long, kind of something like that. So there's a lot of different synonyms we can use to indicate distance or length, but there's really only one word that we have for area. So we know we're doing with arc length here. We need to think then about our angle here. So we have this angle rotating through. They didn't tell us the angle measure, but we can see that it's a semicircle, so we can really use either. We can use theta is a half circle rotation, so 180 degrees, or we could use theta is a half circle in radians, which is pi. The formulas are either easier in radians. So the arc length formula in radians is theta times r. So if we do lane 2, my arc length is going to be 34 pi. My arc length for lane 1 is going to be 33 pi. And how much longer? So we're going to have to subtract them. So if we just do lane 2 minus lane 1, we get 34 pi minus 33 pi, which is just 1 pi, or about 3.14 meters. All right, in this last question, we have 2 boats who are leaving this cape at the same time. One is traveling on a bearing of 42 degrees 30 minutes, and the other on a bearing of 52 degrees 12 minutes. Remember, a bearing is an angle measured from north and rotating towards the east. So the problem tells us that the boats are traveling at the same speed, so approximately how far apart will they be when they're 25 miles from the cape? So again, the keywords that we want to look for, how far apart. So this tells me arc length. My angles are in degrees, so I'm going to use the formula for degrees. So theta over 360 times 2 times pi times radius. I actually need this angle here, so I need the angle between the 2 boats, or the angle between the bearings. So this is going to be my theta value, and to get my theta value, we're going to subtract these. So 52 degrees 12 minutes minus 42 degrees 30 minutes. So remember, you can use your degree minute symbols in your calculator to do that calculation, or you can do the conversions. It doesn't matter. So I use the symbols, which you're going to get with the angle measure, and I got 9.7 when we subtracted. So my theta value is 9.7. So then when I plug in here, I'm going to get 9.7 degrees over 360 degrees times 2 times pi, and then my radius is that distance from, this would be the center of the circle, to where the boats are, which is 25. Again, let's just get an approximate answer here. And we get about 4.23 miles.